The first step to this problem is to find the mass of H2 gas inside the balloon. This mass doesn't change because the balloon is sealed, so it doesn't change no matter what the altitude is. We have the volume of the balloon at STP, and from that we can use the following mole ratios to find out that there's 303 grams of hydrogen gas inside the balloon. Next, we add the mass of the payload and the mass of the balloon itself to the mass of the gas to find the mass of the balloon at its, to find the mass of the balloon. This mass means that if the mass of the air of the same volume outside the balloon is more than this, then the balloon will float, but if it is less than this, the balloon will not float. Next, we need to find the volume of the balloon at maximum height so we can calculate the mass of the same volume of air at different altitudes to see if the balloon will float or not. We use the volume equation with the given radius, which is in feet, to find the volume in feet, and then we use conversions to convert it to liters. To find the mass of the gas at the differing altitudes, we can use the PV equals nRT equation. We have the pressure, which is given to us in millibars, and I converted to atmospheres. Then we have the volume, which is the same as the volume of the balloon at maximum height. We have the gas constant, and then we have the temperature that is given to us in the chart also in Kelvin. From that, we find the number of moles of gas, and we multiply times the molecular weight of air, which is 29 grams, to get the mass of the volume of air at 0 kilometer altitude. We repeat this process for all the different altitudes, which I did in the attached spreadsheet, and we can see that the mass of the balloon, which is 3,203 grams, falls between 30 and 40 meters, and that is our final answer.